Is this screen visible to all? Screen కనిపిస్తుందమ్మా
Yes,
PPT?
Yes, sir.
So in the last class we have started the solar cell and we have studied up to working. Okay. What is the principle involved in solar cell? Principle ఏంటమ్మా solar cell కి?
Photovoltaic effect.
Right, photovoltaic effect. Can anyone define what is the meaning of solar cell? Can anyone define what is solar cell? What is the meaning of solar cell? Can anyone give the definition? ఏం చేస్తాం solar cell యొక్క రోల్ ఏంటి జనరల్ గా?
Converts light energy to electrical energy.
Right, that converts the light energy to electric energy. Right. Okay. And one more question. The N-type player we can call. N-type player in solar cell we can call. ఏమని పిలుస్తాం N-type player? What we can call N-type player here? Right, good. Emitter. P-type player? P-type player means?
Base.
Right, P-type player we can call base. Okay. Introduction we have studied. Okay. That means definition itself that will give the information about solar cell that will convert light energy to electric energy. But that light energy we have to take from sun only. That light energy it has to come from sun only. Okay? Not ordinary light. Okay. And the principle is photovoltaic effect. That's also you know. In construction we are using N-type semiconductor layer that we can call emitter and P-type semiconductor layer that we can call base. Yeah. Then how can we minimize the light due to reflecting? How can we minimize the loss due to reflection? How can we
Anti-reflection film.
Right, by using the anti-reflection coating. By using anti-reflection coating, we can minimize the losses due to reflection. And proper metal contacts are there. And in working also we have studied in the last class. When solar panel exposed to sunlight, the light energies are absorbed by the semiconducting materials. And that light energy, due to that absorbed light energy, what will happen? The electrons are liberated. The electrons are liberated, and that will produce the external DC current. Then how can we convert that external DC current to AC current? How can we convert?
Rectifiers.
Right. By using rectifiers. That means here we can call inverter. By using rectifiers, we can convert DC to AC. For that, we are using the inverters. Okay. By using that inverters, we can convert the DC to 240 volts AC for different applications. And we have started types of solar cells also. How many types we are having?
3 types.
Right, good. Based on materials, we are having 3 types. What is first one? Any idea? Remember? Anyone remember? First one.
Monocrystalline silicon.
Right, first one is monocrystalline silicon solar cells. Second one?
Polycrystalline.
Right, good. Polycrystalline. And third one?
Amorphous
silicon.
Right, very good. These are the 3 types of solar cells. In the last class, we have studied up to here. In the last class, we have studied up to here. We are having 3 types of solar cells based on material used. Okay, that material should be silicon here. That material should be silicon, but the type of silicon we are changing here based on the type of crystal. Okay, type of crystalline silicon. The solar cells are classified into 3 types. First one is the monocrystalline silicon cells. Second one is polycrystalline silicon cells. Third one is the amorphous silicon cells. Okay? These are the 3 types. We have to study one by one. First one, monocrystalline silicon cells. Monocrystalline silicon cells means we have to take pure silicon crystal. We have to take pure silicon crystal. That means single crystal. Okay. See here. Pure silicon crystal means there is no defect. That is pure. That silicon should be pure and defect free. The monocrystalline silicon cell is produced from pure silicon. Generally, that monocrystalline silicon cell is produced from pure silicon. Okay. That is a single crystal. Pure silicon single crystal we have to take. Since the monocrystalline silicon is pure and defect free, then automatically the efficiency of the cell should be higher. The efficiency of the cell should be higher. This is about monocrystalline silicon cells. Here the monocrystalline silicon cell is produced from pure silicon. Generally we can make monocrystalline silicon cell is produced from pure silicon. Then what is the meaning of this? If you take pure silicon, this pure silicon we have to convert into p-type and n-type. That should be important, because in any solar cell we are having two layers. One is the p-type layer, second is the n-type layer. But for making those two, we are using the pure silicon. Okay, in this pure silicon, in this pure single crystal we are taking. Okay, this pure silicon also we are taking single crystal. In that single crystal pure silicon, we are converted into monocrystalline silicon. How we are converting? Half of the part we can dope with trivalent elements, and half of the part we have to dope with pentavalent elements. Then only that will converting into p-n junction diode. Okay, then only that pure silicon is converting into p-n junction diode. That means we are not doing any other methods here. Just we are taking pure silicon single crystal. In that pure silicon single crystal, we are converting into monocrystalline silicon. How we are converting that one? Just half of the part we can dope with the n-type, and half of the part we can dope with p-type. Then p-type layer and n-type layer will form. In between we are having the depletion region. Since the monocrystalline silicon is pure and defect free, then automatically the efficiency of cell will be higher. This is about pure silicon, monocrystalline silicon solar cells. Okay, monocrystalline silicon solar cells. This information. Okay, here what we are doing, that monocrystalline silicon cells is produced from pure silicon. Okay, we are making monocrystalline silicon cells by using pure silicon. Monocrystalline means we have to take single crystal. Monocrystalline means we have to take single crystal of pure silicon. We have to take single crystal of pure silicon. That we have to convert into p-type layer and n-type layer by doping with the trivalent and pentavalent elements. Here this monocrystalline silicon is pure and defect free. Okay, that is pure and defect free. Automatically the efficiency of the cell will be higher. This is about the first one. Next, second one. Second one is the polycrystalline silicon cells. Polycrystalline silicon cells. Here the material we are taking, that is liquid silicon. In polycrystalline solar cell, liquid silicon is used as raw material, and polycrystalline silicon was obtained followed by solidification process. Followed by solidification process. The meaning of solidification process is we have to heat the material. Okay, whatever silicon we are taking, how we can convert it into liquid silicon? That we have to heat up to its melting point. The silicon we have to melt up to its melting point, then that is converting into liquid silicon. Okay? That liquid silicon we can use as a raw material. Okay, that's liquid silicon we can use as a raw material, and that we can solidify. What is the meaning of the solidification? We have to cool that one. Okay, solidification means we have to convert liquid to solid. Remember, actually first 5 letters you can observe solid. Solidification in that first 5 letters solid. Okay, that means first what we have to take, the pure silicon only. First we will take pure silicon. What we have to do, that we have to heat up to its melting point. Then we will get the liquid silicon. That liquid silicon we are taking as a raw material. That we can convert it into polycrystalline silicon. By solidification process. Okay, that means, but in case of monocrystalline we are taking single crystal. As it is we are using in monocrystalline silicon cells. Okay, as it is we are using, just we are doping p-type and n-type metal, that pure silicon single crystal, then we are getting the monocrystalline silicon cell. Okay, in that is pure and defect free, the efficiency should be higher. But in second case, in case of polycrystalline silicon cells, the raw material we are using liquid silicon. How can we get the liquid silicon? We have to take polycrystalline silicon, that we have to heat. Okay, then we will get the liquid silicon. That liquid silicon we have to solidify by using cooling process. Just we can cool the liquid silicon. Okay, at one particular temperature, that liquid is converting into solid. Okay, that we are using here. That is polycrystalline silicon. Okay, the materials contains various crystalline sizes here. But in the first case, single crystal, the size is uniform. Only one crystal is there. But in case of second one, we are using polycrystalline. In this polycrystalline, the crystalline sizes are different here. Not all same crystal size. Okay. Automatically, due to the solidification process, the efficiency will be decreases. Hence, the efficiency of this type of cell is less than the monocrystalline cell. Okay. You can observe here what we are doing. In case of monocrystalline silicon cell, we are using the pure silicon single crystal. Okay, pure we are taking. Just we are doping the p-type and n-type material, and that we can use in solar cell. Here this is pure and defect free, then automatically the efficiency should be higher. In case of second one, polycrystalline silicon cells. In this polycrystalline silicon cells, the raw material we are using liquid silicon. Then how we are getting that liquid silicon? First we have to take the silicon that we have to heat up to its melting point. Then that silicon will be converting into liquid. That liquid silicon we can use as a raw material. Then what we have to do by using that liquid silicon, again we have to get polycrystalline silicon by using solidification process. By using solidification process. And simple. First raw material కింద మనం డైరెక్ట్ లిక్విడ్ సిలికాన్ తీసుకుంటాం. లిక్విడ్ సిలికాన్ రావాలంటే ఏం చేయాలి? We have to take solid silicon only. But that is polycrystalline silicon we have to take. That polycrystalline silicon we have to take and we have to heat that one. Then we will get the liquid silicon. Up to melting point if we heat, then that is converting into liquid. Then that liquid silicon again we have to convert it into solid. That liquid silicon again converted into solid by using solidification process. By using solidification process. That means slowly we have to cool to its freezing point. Okay, slowly we have to cool up to its freezing point. Then that liquid silicon is converting into polycrystalline silicon, that is solid silicon. Then the material contains various crystalline sizes. Whatever polycrystalline silicon we are using, that is having number of crystals, various crystals we are having, and their size is also different. Whatever crystals we are having in polycrystalline silicon, that crystalline size is also different. Okay? Then the efficiency of this type of cell, solar cell, is less than the monocrystalline cell. This is the second. And what is third one? Amorphous silicon. Amorphous silicon means we have to do the silicon layer on a substrate. See here, amorphous silicon was obtained by depositing silicon films on the substrate like glass plate. Substrate like glass plate. Here also what we are doing, here also we have to take the silicon. We have to heat that one up to its melting point. Remember, ikkada difference in the choda. Okay, second process ki third process ki difference in the choda. But here whatever silicon we are using, that is amorphous silicon. In second case, whatever silicon we use, that is crystalline silicon, polycrystalline. Okay, already we know the difference between crystalline and amorphous. Anyone know the difference between crystalline and amorphous? Can anyone give the information regarding that? What is the meaning of crystalline material? Crystalline material
Has regular arrangement of atoms.
Right, very good. There is a regular periodic arrangement of atoms. Okay, that is crystalline silicon. Then what is the meaning of amorphous silicon? Exactly opposite. Okay, there is no regular periodic arrangement of atoms in amorphous silicon. In second process and third process, okay, in both the cases we have to melt the silicon. We have to melt the silicon. But in second process, polycrystalline silicon, we have to cool that liquid silicon slowly. Okay, that process we can call solidification. But here for getting amorphous silicon, we have to cool that one rapidly. We have to cool that liquid silicon rapidly. Then that is depositing as silicon film on the substrate like glass plate. Okay, just we have to heat the crystalline silicon. We have to heat the crystalline silicon. Then we will get the liquid silicon. Then we will get the liquid silicon. That liquid silicon we have to pour on a glass plate. Then we have to cool immediately. We have to cool rapidly. Then automatically we will get the amorphous silicon. Here two things you can observe. In second cases, we are cooling in slow way, very slow we are cooling. That we can call solidification. If you cool, anything you can take, you can heat up to its melting point. Okay, once you get liquid form, then you can cool in very slowly. That process we can call solidification process. You can cool rapidly. That process we can call quenching. Actually, the process name is quenching. They have not mentioned here. Okay, but this process we can call it quenching. For getting amorphous silicon, we have to use the process quenching. Then how we are getting that one? Amorphous silicon is obtained by depositing silicon film. How can we deposit? By heating the silicon only. First we have to heat the silicon, solid silicon we have to take. We have to heat that one. Then we will get the liquid silicon. That liquid silicon we have to take on glass plate. Then we can cool rapidly. Then we will get the amorphous silicon. ఎందుకంటే క్లౌడ్ కవర్కి మీనింగ్ ఏంటి? If you cool slowly, then automatically in that time the silicon atoms arranged regular. If we are giving 10, okay, to separate the silicon atoms we are giving 10 in solidification process. If that is cooling slowly, then automatically the silicon atoms will separate in regular periodic arrangement. That's it that we can call polycrystalline, crystal we are calling. But here we are not giving time to separate the silicon atoms. Okay, once we are depositing the silicon film on glass plate, we are cooling rapidly. Within fraction of seconds we are cooling. Okay, within fraction of seconds we are cooling. Then we are not giving time to separate those atoms in regular periodic arrangement. That's why we are getting the amorphous silicon. Then okay, I don't know how can we cool anything rapidly. ర్యాపిడ్గా కూల్ చేయాలంటే మనం ఎలా కూల్ చేస్తాం? సపోజ్ సిలికాన్ తీసుకున్నామమ్మా, సిలికాన్ మనం సపోజ్ ఒక 700 degrees వరకు హీట్ చేసాం. వీఆర్ హీటింగ్ ది సిలికాన్ అప్ టు 700. సపోజ్ 700 is its melting point suppose. Then the silicon is converting into liquid state. Okay, that liquid state silicon we have to cool to immediately to room temperature. That means 25 degrees centigrade suppose. How can we do that process from 700 to 25 within fraction of seconds? How can we do? For that purpose, what we have to use? Generally, we use liquid nitrogen. Remember, for that purpose, we can use liquid nitrogen. That liquid nitrogen having the temperature of -120, around -120 degrees centigrade. Then that 700 degrees silicon, we have to keep in that liquid nitrogen. Okay. Then within fraction of seconds, the temperature will fall down. That process we can call it quenching. In that process, we will get the amorphous silicon. That means we are not giving time to separate the atoms. That's why we are getting the amorphous silicon. If you give time, that means if you can cool slowly, then we will get the crystalline silicon. You can observe the difference. How we are getting crystalline, how we are getting amorphous. Okay, both are coming from liquid silicon only. That liquid silicon you can cool slowly, then we will get the crystalline silicon. If you cool that one rapidly, then we will get the amorphous silicon. Right? On third one, amorphous silicon was obtained by depositing silicon film on the substrate like glass plate. Okay, that we have to deposit it on the glass plate. That the silicon film. Then we are getting the amorphous silicon. Okay. Then what is its thickness? Okay. Whatever silicon film we are depositing on glass plate, the thickness of the silicon film is around 1 micrometer or less than that. The layer thickness amounts to less than 1 micrometer. Okay, whatever silicon film we are depositing on glass plate, that silicon film, the thickness of that silicon film, that is less than 1 micrometer. For comparison, we are taking the thickness of human hair. Suppose we can take our hair diameter. That the hair diameter thickness or diameter, that is around 50 to 100 micrometers. Remember, actually our hair diameter, that is 50 to 100 micrometers. But whatever layer silicon film we are depositing, that is less than this. That is less than thickness of the human hair. Whatever film we are depositing in amorphous silicon, okay, the thickness of the amorphous silicon layer, that is less than thickness of human hair. That means that is less than 1 micrometer. Okay, and what about the efficiency of these amorphous cells? These amorphous cells having the less efficiency compared with previous two. Compared with the crystalline silicon cells, amorphous silicon cells having less efficiency. The efficiency of the amorphous silicon cells is much lower than that of the other two cell types. Compared with the monocrystalline and polycrystalline silicon solar cells, here this amorphous silicon cells having less efficiency. Okay, and where we use this one? Where we use this amorphous silicon? particularly where we require less power or low power equipment. In that places we can use this one. As a result, actually the efficiency of these amorphous silicon cells are less. The efficiency of the amorphous silicon cells are less. Okay, due to that less efficiency, we use in other different applications. As a result, they are used mainly in low power equipment. Wherever we require low power, in that equipment we use this one. Such as examples, watches and pocket calculators are as facade elements. Okay, that means facade elements means that is where we require low power. Okay? That is low power equipments. These are the examples. This is about the amorphous silicon, and this is completely about the types of solar cells by using different materials. By using different materials. First one we are having the monocrystalline. Monocrystalline means that is pure and defect free. Remember, that is pure and defect free. That's why the efficiency of that one is higher. Second one, polycrystalline. In that polycrystalline solar cells, we are using the raw material liquid silicon. That liquid silicon, what we are doing? Solidification process. By using the solidification process, that liquid silicon is converted into polycrystalline silicon. Okay, that polycrystalline silicon we are using in that solar cell. Okay, but the efficiency of that one is less compared with the monocrystalline. The efficiency of the polycrystalline silicon cell that is less than compared with the monocrystalline. And third one is the amorphous silicon. Actually, this we can obtain by depositing silicon film on the substrate like glass plate. On the glass plate, we have to deposit the silicon films. Okay, in second case and third case, we have to use the liquid silicon. Third, we have to use. In second case, we have to cool that one in very slow manner. Okay, that process we can call solidification. But in third process, we are cooling very rapidly. This we can call quenching. Okay, but here we are not giving time to separate the atoms in periodic manner. That's why we are getting the amorphous structure. Okay, and whatever film we are depositing here, the thickness is less than 1 micrometer. Okay, if you compare with the thickness with the human head, okay, the human head thickness is 50 to 100 micrometer. That means whatever film we are depositing in amorphous silicon cells, that is less than thickness of the human head. And the efficiency of these amorphous silicon cells are very less. Okay, much lower compared with the other two types. That means monocrystalline and polycrystalline. Then, due to this less efficiency, we are using in low power equipment. As a result, they are using mainly in low power equipment. Examples: watches and pocket calculators, or finally we can say facade elements. Right? And what about the efficiency values? What about the efficiency values? If we use monocrystalline silicon, the efficiency we are getting 14 to 17%. 14 to 17%. If we use the polycrystalline silicon, the efficiency we are getting 13 to 15%. If we use the amorphous silicon, the efficiency we are getting 5 to 7%. See, actually water efficiencies here they have given. That is very old one. That is very old values. Actually, day by day research is going rapidly. Okay? Day by day research is going on rapidly. Now, actually the efficiency right now we are getting around 42%. Remember, present whatever solar cells we are using at present commercially, the efficiency we are getting up to 42%. Okay, and మనకి ఏమవుతుందంటే డే బై డే మెటీరియల్స్ చేంజ్ అవుతుంది. డే బై డే మెటీరియల్స్ చేంజ్ అవుతుంది. ఎందుకంటే రీసెర్చ్ ఇస్ గోయింగ్ ఆన్ ఇన్ లార్జ్ వే. Okay, actually different scientists are using different materials to improve the efficiency. Okay, at present they reach a maximum efficiency of 42%. Okay, this is general values. Okay, these are the general values. These values before 4 years, not exact right now. Okay, these are, but compared with all, monocrystalline silicon will give more efficiency. Actually, by using different techniques, by adding different materials to this monocrystalline, okay, now we increase the efficiency up to 42%. Efficiency increase up to 42%. Okay, but whatever exam point of view, we have to remember that is these values. Okay? Monocrystalline we will get 14 to 17%, polycrystalline 13 to 15%, amorphous silicon 5 to 7%. But in research point of view, we have to take other values. Okay, because whatever books we are studying, those are printed before 3 years or 4 years. Okay, that time values they have given. But at present, the values are up to 42% we reached. This is about efficiencies and types of metals we are using in solar cells. Okay, this is about efficiencies and the types of materials we are using solar cells. Okay, we are having 3 types of solar cells: monocrystalline, polycrystalline, and amorphous. And here this is points about the amorphous solar cells, and these are the efficiencies. And the next topic is very important, characteristics. Characteristics are very important. Characteristics are very important. Particularly here we are studying two types of characteristics. One is the IV characteristics and second is PV characteristics. IV characteristics and PV characteristics. Here the heading I have given only IV characteristics and two graphs we are seeing here. This diagram we are having the two graphs. See, left side we are taking the current, that is I, and on x-axis we are taking voltage, on right side we are taking power. Two graphs are there. Okay, this one y-axis we are taking current and x-axis voltage. This graph will give the IV graph. This one from here that will start from I maximum. This blue color graph will give the IV characteristics. This blue color graph will give the IV characteristics. This violet color graph will give the PV characteristics. That is PV curve. Okay. Now I will explain about this graph. IV characteristics means we have to study about this graph. Actually in syllabus they have given only characteristics. They have not mentioned IV or PV. That's why we have to study both. Okay. In syllabus they mention only characteristics. That's why I am explaining both IV characteristics and the PV characteristics. Okay. Whatever solar cell we are taking, in that we have the values we have to note down. Current values we have to note down. Voltage values we have to note down. Just you can multiply both. Then you will get the power. Okay. Actually, we have to note down the current values and voltage values by using ammeter and voltmeter in solar cell. Okay, in next lab I will explain about solar cell experiment only. In that, how we can note down the current values and voltage values by using solar cell. Okay, and by using that current and voltage, okay, we can calculate the power. When we are doing that experiment, we will get one doubt, no doubt at all. When I explain చేసినప్పుడు doubt వస్తుంది. ఆ డౌట్ ఏంటంటే మనం ఇక్కడ ఇంట్రడక్షన్ చెప్పినప్పుడు వాట్ ఎవర్ ఐ ఎక్స్ప్లెయిన్ ఇన్ దట్ ఇంట్రడక్షన్ we are using the light coming from sun, but in our experiment, okay, we are not using that light from sun. In our experiment we are not using the light coming from sun. Why we are doing like that, I will explain that lab. But actually we have to use mainly the light coming from sun. Okay? But in our experiment, when we are doing experiment, we are not taking light from sun. Okay? Why we are doing like this, I will explain that experiment. See here, these characteristics we will study one by one point. We are having total 4 points. Here we are having total 4 points. Okay, we will check one by one. See, this is the first graph. First we will study about the IV characteristics. IV is current, that is on y-axis. Voltage is on x-axis. Okay? The above graph shows the current to voltage characteristics of a typical silicon PV cell. PV cell means photovoltaic cell. Okay, what is the another name of silicon solar cell? What is the another name of solar cell?
Photovoltaic.
Right, another name is photovoltaic cell. Here, whatever graph we are observing here, the above graph shows the voltage current characteristics of a typical silicon PV cell operating under normal conditions. Actually, two graphs I will explain. First, one graph is IV graph. Okay, current versus voltage characteristics. The above graph shows the current versus voltage characteristics of a typical silicon PV cell operating under normal conditions. This is the current voltage characteristics. Current versus voltage. Current is on y-axis, voltage is on x-axis. Then whatever power delivered by a solar cell, how can we calculate? That is the product of current and voltage only. Okay, whatever power we are getting by using the solar cell, that how can we calculate that power? That is product multiplication of current and voltage. See here, the power delivered by a solar cell is the product of current and voltage. Okay, if you multiply both, we will get the power. If the multiplication is done point for point, okay, every point we have to multiply. See, from I maximum to V maximum. Okay, from this complete blue color, actually every point the current value, voltage values will changes. Okay, at point to point we have to multiply, then we will get the different power values. Okay, for all voltages from short circuit to open circuit conditions. This point we can call short circuit, this point we can call open circuit. I will explain those terms also here. The power curve above is obtained for a given radiation level. This is the power curve. This violet color curve, that is the power curve, and this blue color, that is the IV curve. That is the first point. In first point, what I am explaining, the above graph shows the current voltage characteristics of a typical silicon PV cell operating under normal conditions. Then how can we calculate the power delivered by a solar cell? That is the product of current and voltage. Just we can multiply power and voltage, then you will get the power. Just we can multiply the current and voltage. Just you can multiply current and voltage at each point, then you will get the power for all voltages from short circuit to open circuit. Then the power curve above is obtained for a given radiation level. This is the power curve. Okay? This is first point. The first point, just I explained about the IV characteristics. How can we calculate the power? In what range we have to calculate? From short circuit to open circuit, we have to calculate the power values. The power graph also we have given here. That is first point. In the second point, here in the second point, mainly we have to know about the what is meaning of VOC. Okay, open circuit voltage. Okay, VOC means open circuit voltage. What is the meaning of that one? Short circuit current. And what is the meaning of that? Now tell me that VOC, that open circuit voltage, what is the current value? What is the current value at open circuit voltage?
0.
See, this is right, good.
0.
That is the right 0. Open circuit, circuit is open, then no current is flowing through that circuit. Okay, then current will flow. If the circuit is closed, then only current flowing through the circuit. Here itself, it is representing circuit is open. Open circuit voltage means there is no current flowing through the circuit. That means the current is minimum, that is 0. Then short circuit current. So at this point, at the short circuit current value, what is the voltage value?
0.
0. Short circuit current means there is no resistance. Remember, there is no resistance. If we are having resistance, what will happen? That opposes the flow of current. That opposes the flow of current. If there is no resistance, directly you can connect positive and negative wires directly. We can connect the positive wire and negative wire directly. Then automatically the circuit will be shorted. The circuit will be shorted. Okay, in that case, voltage will be 0, current will be maximum. Okay, we will check those 2 points here. See, if the solar cell open circuited, that is not connected to any load. We are not connected to any circuit. Not connected to any load means there is no resistance. Okay, and even the circuit is not completed. Open circuited means the circuit is not completed. Okay, the circuit is open. If the solar cell open circuited, that is not connected to any load. And what about the current value? The current will be at its minimum, that means 0. And the voltage across the cell is at its maximum. Okay, voltage will be maximum. In that case, current will be minimum. Then that point we can call open circuit voltage Vs, known as the solar cell's open circuit voltage. That point we can call open circuit voltage of the solar cell. That is first one. This is one extreme point. Then come to other extreme point. This is the other extreme point. Okay. At the other extreme point, when the solar cell is a short circuited, what is the meaning of the short circuited? That is the positive and negative leads connected together. Okay. So what is the meaning of short circuit? At the other extreme, when the solar cell is short circuited. Short circuited means positive and negative leads connected together. Okay. That is the positive and negative leads connected together. Then what will happen? The voltage across the cell at is minimum 0. The reason is the resistance should be 0. In case of short circuit, the resistance should be 0, and automatically voltage should be minimum, that is also 0. The maximum current is flowing through the circuit, but the current flowing out of the cell reaches its maximum. Okay, that we can call short circuit current. That we can call short circuit current. When we are drawing the current versus voltage characteristics in solar cells, that we have to start from short circuit current to open circuit voltage. That we have to draw from short circuit current to open circuit voltage. Okay. In case of open circuit voltage, the circuit is open. There is no current flowing through it. That means the current value is minimum. That is 0. Then the voltage across the cell, then that is maximum. That we can call open circuit voltage. Come to other extreme position. Here at this point, the solar cell is short circuited. Short circuited means positive and negative leads are connected together. Then the voltage across the cell is minimum, that is 0. Then the current flowing through the cell reaches its maximum, that we can call short circuit current. Any doubt in short circuit current and open circuit voltage?
No, sir.
Okay, everyone clear? Right. Next, third point. Particularly, we have to focus on those two. Okay. Yeah. See, actually, in third point, if you study about the graph, then the span of solar cell IV characteristics, that means complete graph we are studying now. Okay. from short circuit current to open circuit voltage. The span of solar cell IV characteristics curve means that is ranging from short circuit current to open circuit voltage. Remember. Then the span of the solar cell IV characteristics curve ranges from short circuit current to, that means, zero output volts, and open circuit voltage. Open circuit voltage means zero current. Okay, here we have to draw the graph from short circuit current to open circuit voltage. Short circuit current means that is that voltage zero output volts. Open circuit voltage means zero current. Okay, that we have to draw the graph. That means the span. Span is complete range. Okay, that range from I maximum short circuit current to open circuit voltage. In other words, the maximum voltage available from a cell is at open circuit. Already మనకు తెలుసు. Okay, where we are getting maximum voltage, that is at open circuit, and the maximum current where we are getting at closed circuit, that is short circuit. Of course, neither of these two conditions generates any electrical power. Okay, now tell me what is the power at this open circuit voltage? What is the power value at open circuit voltage? What is the formula for what is value?
0.
Right, because the current is zero, then formula for power is V into I. The current is zero, then power will be zero. Now tell me what is the power value at short circuit current?
0.
0.
That is the right. That is also zero. Here, of course, neither of these two conditions. These two conditions means one is at short circuit current, second one is at open circuit voltage that generates any electrical power. Okay, neither of these two conditions generates any electrical power. In those two cases, we are not getting any electric power. That is zero. But between those points, but there must be a point somewhere in between where the solar cell generates maximum power. If you observe from short circuit current to open circuit voltage, we are getting the power. At one point, the power should be maximum. At one point, the power should be maximum. That we can call maximum power point. Okay. At one point, the power should be maximum. We have to study about that point that we can call maximum power point. We can observe this here. This point. Here we are drawing the graph from ranges short circuit current to open circuit voltage. Okay, that means maximum voltage to maximum current. Maximum voltage we are having at open circuit and maximum current we are having at a short circuit. In both the conditions, okay, the power should be zero. Okay, neither of these two conditions generates any electrical power. But somewhere in between that curve, between the 2 points on the curve, the power should be maximum at any one point. Okay, that point we can call maximum power. Okay, next we will study about that. See here. However, there is one particular combination of current and voltage for which the power reaches its maximum value. మీకు ఎక్కడైతే current value maximum, voltage value maximum ఉంటుందో, if you multiply both, then you will get the maximum power. Then you will get the maximum power. That is this one. That means right side top corner. Right side top corner, we are getting the maximum power. See. However, there is one particular combination of current and voltage for which the power reaches its maximum value at IMP and VMP. IMP means maximum current, okay, maximum current point. VMP means maximum voltage point. In other words, the point at which the cell generates maximum electrical power, and this is known as the top right area of the green rectangle. If you can observe this green rectangle, okay, actually here we are getting the maximum. Okay, where we are getting maximum power, that corresponding current we can call maximum current point. Where we are getting maximum power, that corresponding voltage we can call maximum point voltage, maximum voltage point. If you multiply those two, we are getting maximum power. Multiply those two, we are getting maximum power. Okay, just we can take one right angle, one rectangle here. Okay, this green color area is the presence of rectangle. Then the top right area of the green triangle, that point will give the maximum power point. This is the maximum power point MPP. Therefore, the ideal operation of a photovoltaic cell is defined to be at the maximum power point. Okay, always we have to operate the solar cell at the maximum power point condition. Then only that will give maximum power. Then only that will give maximum power. This is about IV characteristics. This is about IV characteristics. Just check once again this last point. Here what we are doing. Here out of all the current voltage values, okay, one combination will give maximum. One combination will give maximum value of the power. Okay, that maximum value of the power where we are getting, that corresponding current we can call maximum current point, and corresponding voltage we can call maximum voltage point. Okay, but current is maximum short circuit. But at that point, the power is zero. Voltage is maximum open circuit. At that point, power is zero. We are not taking those 2 points. We are not taking those 2 points. In between that, just we can take different values of current and voltage. We can multiply this. Okay, where we are getting that maximum power value. Okay, corresponding that current and voltage at that power, that we can call maximum current point and maximum voltage point. Okay. However, there is one particular combination of current and voltage for which the power reaches its maximum value. Okay. At IMP and VMP. In other words, the point at which the cell generates maximum electrical power, and this is shown at the top right area of the green rectangle. Okay, this is the green rectangle. Top right area is this one. That point is the maximum power. This is the maximum power point MPP. Therefore, ideal operation of photovoltaic cell is defined to be at the maximum power. Always we have to study solar cells at the maximum power point condition. These are the 4 points we have to study here. These are the 4 points we have to study here. See, actually in the 4 points, first point explaining about the graph. Okay, what are the curves we are drawing? We are drawing current versus voltage and power curve. Okay, power curve and voltage versus current curve. Both graphs we are drawing here. This is the first point explained. Second point explains about the short circuit current and open circuit voltage. Second point explains about short circuit current and open circuit voltage. And the third point explains about the complete range between short circuit current to open circuit voltage. Okay, at the 2 points we are getting the zero power, but at some point between those short circuit current to open circuit voltage, some point will give maximum power. Okay. This third point explaining about that. The last point will give the information about the MPP, maximum power point. These are the 4 characteristics of solar cell. This we can call characteristics of solar cell. Next, we have to study advantages, disadvantages, and applications. Very simple one. Advantages of solar cell. What is it? It is clean and non-polluting. Okay. Can we get any pollution by using solar cell?
No,
Not any pollution. Okay, if you use solar cell, there is no pollution. Okay, it is very clean and non-polluting. Right. Second one, it is a renewable energy. It is not non-renewable. It is a renewable energy. Okay, solar energy is the renewable energy. You can continuously use. Okay, that is natural source. Whatever source we are using here, that is natural source. That is sun we are using. Okay, the light coming from sun we are using. That's what we are calling. This is a renewable energy. Okay, it is a renewable energy. Third one, solar cells do not produce noise and they are totally silent. When we are using solar cells, we won't get any noise. It is completely silent. And next, they are long-lasting sources of energy which can be used almost anywhere. These are long-lasting sources of energy. The sun is forever. Okay, sun is for in daytime. That is for forever, which can be used almost anywhere because sun is available everywhere in the universe. Okay, we can use everywhere the solar cells. They require very little maintenance. Once after installation, the maintenance should be almost minimum. Almost minimum. After installation, the maintenance should be almost minimum. After installation, remember that part. They have long lifetime. One time you can install, then that will give long lifetime. Okay, 7 years, 8 years minimum that will give. There are no fuel cost or fuel supply problems. Here we are not giving any fuel. That is, there is no fuel cost. Just that will take the energy from sun only. Okay? These are the advantages. You can check one by one. It is clean and non-polluting. It is a renewable energy. Solar cells do not produce any noise and they are totally silent. They are long-lasting sources of energy which can be used almost anywhere. They require very little maintenance. They have long lifetime. There are no fuel cost or fuel supply problems. These are the advantages. Then what are the disadvantages? Solar cells or solar panels are very expensive, remember. After installation, maintenance is very less. After installation, almost there is maintenance free. But for installation, we have to purchase solar cells. Those are very expensive. That is first point. Second point, energy has not to be stored in batteries. But whatever energy we are getting from solar cells, okay, that we can't store in batteries. That is the old point. But now we can store it. That energy. But problem is there in that. The problem is whatever energy we can get by using solar cells, we don't have that much efficient batteries. Remember, we don't have that much efficient batteries to store that much large amount of energy. Previously, we don't have batteries directly, we can use. Now we are having batteries to store that energy. But if you convert complete that light energy to electric energy, we don't have that highly efficient batteries. That research is also going on. Okay, that means energy has not to be stored in batteries. That is one of the disadvantages. Third one, air pollution and weather can affect the production of electricity. Air pollution, if there is more air pollution, then we won't get much sunlight. We won't get much sunlight. And weather also, weather conditions also important, particularly in rainy season. Particularly in rainy season, we won't get that much efficiency. Okay, air pollution and weather can affect the production of electricity. And next one, they need large area of land. This is area. Aim is saying they need large area of land to produce more efficient power supply. Okay, for producing more efficient power supply, we need large area. And sun does not shine consistently. Okay, sun does not shine consistently. Only daytime is possible. Okay, in some countries, particularly North European countries like Norway, Finland, Sweden, Denmark, in that country, 6 months there is no sun. In 6 months, around 6 months, they won't get sunlight. Okay, in that case, is also problem. And less efficient, costly equipment. And whatever present we are reaching up to maximum 42%. That is less only efficiency. And equipment cost is also very high. And reliability depends on location. Location to location, that will change. These are the disadvantages. And what are the applications? Okay, where we use the solar energy. Main application, we can use domestic power supply, electric power generation in space. In space also, we are using solar cell energy. Drying agricultural products. Solar pumps are used for water supply, water heating, that means water heaters, generating electric power to providing electric power to satellites. And these are all other applications. We use in cell phones, spotlight, fans, coolers, satellite panels, solar car, okay, fluorescent lighting, television, sump pump, laptop. These are all different applications of solar energy. These are all different applications of solar energy. Okay? These are limited. We are having more applications. Okay? Here we have only few applications. We are having a lot of applications of this solar energy. We are having the lot of applications of solar energy. Right? This is about solar cell. This is completely about solar cells. First, starting from principle, introduction. That is definition. Introduction is definition. After that, principle, construction, working, types of materials we used. Okay, characteristics, advantages, disadvantages, and applications. This is about solar cell. Okay, and here at present, what research is going on? See, whatever energy we are getting by using solar, by using sun, we don't have that much efficient batteries. That's why the future for electrical vehicles is very good. Okay, the future for electric vehicles. Okay, that is very good. That means in that they are using the batteries only for storing energy. Okay, if you make efficient batteries, then automatically that will get more advantages. That is having more advantages. Okay, actually the research is going on. Not in your just you can check in your mobile. Okay, if whatever battery you are using in your laptop or mobile. Okay, nowadays we are getting the inbuilt batteries in mobiles. Nowadays we are getting inbuilt. We can't observe, but you can observe your laptop battery or mobile battery. They have written lithium-ion battery. They have written on that lithium-ion battery. Okay, presently we are using that only, but in future that will change. Lithium sulfur battery and the lithium air battery. If we get that lithium air battery into market, your mobile you will get minimum 30 days charge. Present మీకు maximum వస్తే ఒక 2 days వస్తుంది maximum. సో మనమైతే 24 hours ఆడితే కష్టం. మనం చేసి యూజ్ చేసే యూసేజ్కి ఓకే అంటే మన చాలా యాప్స్ ఉంటాయి కాబట్టి by using that we will get maximum 24 hours. Okay, because of that lithium ion battery. If we replace by lithium air battery, that will take time to get into market. Then automatically your mobile will get minimum 30 days charge. Okay? 30 days to discharge completely. Okay, this is about solar cells. In next class we will start pin diode. You have doubts on indlo? Solar cell have doubt unda? Any doubt in solar cell?
No, sir.
Okay, doubt em ledhu kada indlo?
No, sir.
No, sir.
Right. Okay, next class I will start the pin diode. Next class I will start pin diode. Okay. Okay, I am leaving now.